Classes are useful for grouping relevant data and methods into one object. Classes are like factories for creating instances, and classes by themselves aren't useful for the most part, only the instances that they create are. I'm going to visually represent classes like this as a factory, and I'm going to represent the instances that they create like this. And notice that every instance here has a blue tip to indicate what class it came from. We can create an empty class named myClass by saying class, and then the name of the class we want to create, and then open and close parentheses and colon. And that's going to create a class named myClass, so we have variable myClass that points to a class object. In that class, we typically define methods, so notice here I'm saying method and not functions. Methods are just like functions, except that they belong to classes. Methods always have at least one argument, and that first argument should always be called self. I'll discuss what that means in a bit. Visually, I'm going to represent methods similarly as I do functions with this object, except I'm going to represent self with one of these puzzle pieces. So far, our variables values table looks like this. We defined a class with one method named myClass, but we haven't actually done anything with it. Now let's create an instance of myClass. We create instances with the same syntax as calling a function, except instead of calling a function, we're using it to create an instance. So we type the name of the class, myClass, and then open and close parentheses, and we might have in some arguments here, as I'll discuss in a little bit. So now inst1 is an instance of myClass. Instances can have what are called instance variables. We set instance variables by typing the name of the instance, and then dot, then the name of the instance variable, and we say equals, in this case I'll assign it to 10. So what this is saying is that this instance, inst1, has an instance variable named instance var, and its value is 10. So I'm going to put that inside of this instance object. Now, whenever Python looks up an instance variable, it first looks at the instance to see if it can find it, and then it looks at the class that created that instance to see if it's there. So for example, if we call inst1.doThing, then Python is going to look for the doThing method in the instance variable first, but it doesn't find it there, so it looks in the class myClass where it does find it. And remember how I said methods were slightly different from functions, and how the first argument to a method is always self? The reason for that is that when we call a method, the instance object is always passed in as the first argument to the method. So here, when we call instance1.doThing, then even though we only passed in one argument ourself, then the instance1 already was automatically passed in as the first argument to doThing. And then 5 or any other arguments that we passed are passed in after that. So here in this call to doThing, then self is instance1 and num is 5. And that means that when we call doThing, and if we ask for self.instanceVar, then we get 10. And we add that to num, or 5. And then when the value of this call to instance1.doThing when called with 5 is 15. So there are a few methods on classes that are optional. Whenever we create a class instance, there are a few things that happen. First, there's this special method called __init__, and it's called the constructor. What we're going to do is we're going to always put the code for setting instance variables inside of this constructor. And the constructor also specifies which arguments we need to provide when we create a new instance of myClass. So whenever we create an instance of myClass, like so, then there are a few things that are going to happen. First, we create an empty instance that has no instance variables set. Then we're going to call the constructor and pass in whatever arguments were specified, And remember how we pass in this instance as the first argument, or self. So here, if I'm calling my class with 5 as the first argument and Joe as the second argument, then 5 gets passed in for A and Joe gets passed in for B. And in the constructor here, we're going to set some instance variables by saying self, remember that's the instance object itself, and then dot in whatever instance variables we want to set. So here, if I set self.x to a plus 5, then self.x gets 5 plus 5, or 10. So now this new instance has an instance variable x set to 10. We set self.y to be b, or in this case, we set it to be Joe. So that creates another instance variable for y. And then we're going to set self.z to be 106, which creates a third instance variable on the instance that we're creating. Then after we're done calling our constructor, we give back our instance for this call to my class. So what that means is that in this class, which has this constructor, when we create a new instance, when we pass in 5 for A and Joe for B, then we get back a new instance that has these instance variables set. So x to 10, y to Joe, and z to 106, because of the way that this code worked. So let's see that in action. So here we have a class for person. The first line sets current year to 2018. And then we create a class person. It has a constructor that accepts n, or a name, or y, or a year born. And there are two methods. So there's getAge, and there's this underscore underscore str underscore underscore method, which controls what gets printed out if we print out a particular instance. So again, we've set current year to be 2018, and we've set person to be this class, but we haven't created any instances yet. So let's create an instance of person. I'm going to create an instance of person and pass in Ada Lovelace as the name and 1815 as the year. And again, what this is going to do is first it's going to create a blank instance, and then it's going to call our constructor, or underscore underscore init underscore underscore, on that constructor, and we're passing in Ada Lovelace for n and 1815 for y. And this constructor sets name to Ada Lovelace and year born to 1815. And after that, it gives back this instance. So now we have an instance which we're assigning to Ada, which has two instance variables, name and year born. So let's create another instance. I'll set the name here to Alan Turing and the year born to 1912. And the same process results in an instance with two instance variables, name set to Alan Turing and year born set to 1912. So here we have two instances of person, Ada and Alan. And let's say that we print ada.getAge. The first thing that Python is going to do is it's going to ask, where is this getAge method? It first checks the Ada instance to see if this instance has an instance variable getAge. Well, it doesn't. So then it goes and checks the class that created Ada and sees that it does have a method getAge. And when it calls getAge, then Ada is passed in as self. So here self is Ada. And that means that when we ask for self.yearborn or Ada.yearborn, then we get 1815. And when we take 2018 minus 1815, then we get 203, meaning that this expression prints out 203. When we print out Alan.name here, then we first check if the Alan instance has an attribute name, and it does. It's set to Alan Turing, so this prints out Alan Turing. And then finally, when we print out Ada, then the str method is called with self set to Ada. And what that prints out is Ada Lovelace, age 203. So classes are like factories that create instances. The classes by themselves aren't useful, but the instances are, and they allow us to group relevant data and methods. When designing a class, you should first ask yourself what every instance represents. What should they store? What operations might you do on instances? If you find that you would only need to create one instance, then you might not need to represent that data using a class. Maybe a dictionary would be sufficient.